Welcome to this lecture series in complex numbers. In this lecture, we'll be discussing a theorem which is written in this fashion, and I can't pronounce this, it's a French name, but perhaps I'll just stick to de Moivre's theorem or something, but the correct pronunciation is on the lines of de Moivre's or something like that. Anyway, so we saw that cis theta times cis phi is cis theta plus phi, where cis theta is just a lazy shorthand for cos theta plus I sine theta. So that, and let us also recall a simple algebraic identity which one must have seen earlier. Even if you haven't seen earlier, that's fine. Suppose a plus b plus c is 0, then a cube plus b cube plus c cube is 3 times abc. The proof is this. It's the factorization result, that this expression factorizes that way, and that's it. So this is true equally for complex numbers. It's not like you need a, b, c to be real numbers or anything. It's just this factorization is independent of any real, complex, rational, or any such thing. Okay, so let's quickly look at the problems. These are the three simple problems for practice. And now let us quickly prove this theorem. So suppose there is a complex number which is given in that way. So it's r cis theta. Then what is z square? Z square is r square cis theta square, which is r square cis theta, which as we saw is cis theta plus theta, and thus this is r square cis 2 theta. And if you just continue with this reasoning, you will see that z to the n is equal to that. So this is an inductive proof. If you want to be completely formal, you can prove this via induction, but it is clear what's going on. So it's not a new theorem, really. It is basically an enunciation or a special instance of this fact. Okay, so this has a name. Very nice. Okay, fine, great. And let us look at its application. It's a simple theorem, but it's a powerful theorem. So suppose we have alpha, beta, gamma, and angles are angles with this property and that property simultaneously. Then we want to show that a and b hold. Okay, looks a bit daunting if you just think of it purely trigonometrically, but with the right perspective, it is immediate as to how to show it. So define z as cis alpha, w as cis beta, and tau as cis gamma. And the hypothesis says precisely that this is 0. Why is that? Because the real part of this guy is this, and the imaginary part of this guy is that. So via this equation, we deduce this. And now by using the recall, we get z cube plus w cube plus tau cube equals 3zw tau, which gives us cis 3 alpha plus cis 3 beta plus cis 3 gamma equals 3 times cis alpha plus beta plus gamma. Why is that? Because z is cis alpha, so z cube is cis 3 alpha. This is the de Moivre's theorem. W is that, the left side follows that way. For the right side, we have cis alpha, cis beta, cis gamma, so it's cis alpha plus beta plus gamma. Okay, wonderful, which implies real part of the LHS is real part of the RHS, and imaginary part of LHS is imaginary part of RHS. And thus, if you look at the real parts, just compare the real parts, you will get the second one. And if you compare the imaginary parts, you will get the first one. And that's it. That's a very simple proof of this daunting looking problem. So just keep an eye out for such applications. And with that, I want to end this lecture. As usual, like, comment, share, subscribe. I also have Patreon. The link is in the description below. Thank you for listening, and I'll see you next time.